In this section, we want to talk about how you combine functions using different operations like addition, subtraction, multiplication, division. The addition subtraction ones are fairly straightforward. It's the idea that you're taking one function and another function, combining them together using addition. We're going to do this and then find what the sum is when the x variable is 4. Also for these, we want to look at the domains of the resulting functions. So for your first one here, you see f plus g of x. F plus g of x can also be written as f of x plus g of x. Once we see this way, it's a matter of substitution. We want to go ahead and put in 2x plus 1 for the f function and 2x squared minus 4 for the g function. Combining like terms, this is f plus g of x. So that's our first step. Then they want us to find the sum when x is 4. So up here, f plus g of 4 is the same thing as 2 times 4 squared plus 2 times 4 minus 3. So we say the sum would be 37. The sum of plain x and then the sum when x is 4, 37. Lastly, then, the domain of this guy. When we're talking about domain of functions, we talk about what values are valid for an input. There's no restriction for a plain linear or for a plain quadratic. There's no restrictions in terms of there's nothing underneath. There's no fractions in here. There's no skips, no jumps. So when we combine something that has no restriction with something else that has no restriction, the result should be no restriction. We can also look at the resulting function here. It's a quadratic. If we were to graph it, it would pass our vertical line test, no problem. So we say domain, negative infinity to infinity. For this next one, very similar, except now we're looking at the difference. We'll also evaluate and find a domain. When you're doing a difference, you do need to watch out so that when you say f of x minus g of x, notice that that minus is for the entire g function. So this becomes x squared minus, I usually put parentheses around the second function just to remind myself, oh yeah, that negative is going to apply to everything. So when I put in 1 minus x, I have x squared minus 1 plus x. So there's the difference. Then we're supposed to evaluate when x is 2. And then lastly, again, for our domain, no restrictions on the x squared, quadratic, g of x is a linear. There's nothing in the denominator we need to worry about, so we'll say the domain is, again, all reals. Notice that for these ones, the f and g functions here were different from the f and g functions here. That's okay. Just use whatever you're given in the problem to do your operation. So make sure you pay attention to what they give you. They can change it from problem to problem. This next one here is going to ask you to find a quotient, or excuse me, a product, when you see the f next to the g here, f times g, and then they're going to ask us to put in the x plus 6. We've actually already been doing this. We've just been doing it in 2 steps. We've been doing like f minus g of x, and then once we have that, we've been plugging in the 2. They're just asking us to do this all in one step. They're just saying find the product, and then instead of putting in an x, we're going to put in an x plus 6 when we evaluate it. So for our first one here, we'll say fg of x is the same thing as f of x times g of x. F of x is x squared, and g of x is 1 minus x. So our product is going to be x squared minus x cubed. So that's f of g of x. To go one more step and to say, okay, but what if we substitute x plus 6 everywhere we see the x? So this first one squared, x plus 6, x plus 6. This is now fg of x plus 6. And then to simplify this out. Again, remember that this negative is going to affect everything inside of there. So we will really have negative x cubed. I'm going to actually just change all these right now. Negative, 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 negative. Negative x cubed, 17x squared. So this is the simplified version of f times g of x plus 6. And then again, if they were to ask us for the domain of this, we'd want to check what's the domain of the first, what's the domain of the second. No problems. Even the resulting is a cubic. So if they had asked for our domain, we'd say negative infinity to infinity.